In this video, we're going to look at another application of volumes of revolution, and in this case, we're revolving about the y-axis. We're applying the disk method. So the question here is find the volume of the solid obtained by rotating the region bounded by the parabola of y equals x squared, horizontal line y equals 4, and x equals 0. X equals 0 is the y-axis. We're revolving this region about the y-axis. Now, since the bounded region is being revolved about the y-axis, we slice the circular cross-sections perpendicular to the y-axis and integrate with respect to y. The most important part is defining the radius of rotation. So what is the radius of rotation? Clearly, the radius of rotation is an x quantity. This is the radius of rotation. But we need x in terms of y. So let's do that. We have y equals x squared. Y is equal to x squared. Let me change color back. So y is equal to x squared. Square root both sides, and we get x is equal to plus or minus root y. We're going to only look at x equals root y, the positive radius. So this is the radius of rotation, and we've defined it in terms of y. All right, so the radius is x, and x is equal to root y. And now we have the volume of one of these disks. What is the volume of one of these disks? Well, the differential volume is going to be pi times the radius squared. Well, the radius is x, and x is equal to root y. Pi times root y squared times dy. And that's the volume of one of the disks. And the integral adds up all of these disks in the y direction, and we get the entire volume of the solid of revolution. All right, let's go through the mechanics of this question. So what is a disk radius? Disk radius. The disk radius r is equal to x, and x is equal to root y. So this is a disk radius right here. All right, what is a disk volume? The disk volume, dv, is equal to pi times radius squared. Radius is x, so pi x squared dy. That's equal to pi times x is root y. Let's substitute that in. We get root y squared dy. So the disk volume dv is equal to pi times root y squared. Root y squared is just y. Pi y dy. This is what we're finding here, the volume of this disk. So that's pi times radius squared times dy. And once we find one of the volumes of these disks, we add up all these disks in the y direction and find adding up the disk gives us the entire volume of the solid. So the volume is just going to be the integration from y equals 0 to y equals 4 of all these little disks that we find, pi y dy. All right, so pi y is the volume of the disks. So we really need to stress that. And the integral basically adds them up in the y direction, and we find the entire volume of the solid. The entire volume of the solid looks like this. Basically, when we revolve this region about the y-axis, you can see how we're getting this paraboloid, basically, that's going up like that. So this is the solid. All right, now it is the easy part, computing this integral. We get volume is equal to, let's pull pi out, pi integral 0 to 4, y dy, that's pi times y squared over 2, from 0 to 4, volume is equal to pi over 2, times y squared, put 4 in, substitute 4 in, we get 16, substitute 0 in, we get 0, 16 over 2, that's 8 pi. This is the volume of revolution. All right, so now the next question is find the volume of the solid obtained by revolving the region y equals x squared, y equals 4, and x equals 0. This is the same region as we had before. But now we're not revolving about the y-axis, which is what we did in the last question. We're revolving this about y equals 4. Now, notice that so let's actually find the points of intersection. The point of intersection is we obtained by y equals y. That means x squared is equal to 4. Now solve for x, we get x is equal to plus or minus 2. So we'll just take x equals 2. Now notice that the bounded region is being revolved about the line y equals 4. The line y equals 4 is parallel to the x-axis. So the cross-sections, the circular cross-sections are perpendicular to the x-axis. They're also perpendicular to the line y equals 4. And we're going to integrate with respect to x. We're going to add up all these disks in the x direction. That's what the integral does. And we find the volume of the entire solid. All right, let's define the disk radius. This is the most important part of the question, defining the disk radius. The disk radius is 4 minus x squared. Let's go over that. This is very important. How do we get that? The distance from y equals 4 to the x-axis is just 4. That's y equals 4. The distance here is y equals x squared. The difference of those two heights gives us the radius. So that gives us this radius here, and this radius is equal to 4 minus x squared. So that's the disk radius. Now let's talk about the disk volume. What is the disk volume? Well, this is going to be dv is equal to pi times radius squared. We found the radius. The radius is 4 minus x squared. 4 minus x squared, all squared. Now let's compute the volume. Let's set up the definite integral for computing the volume. Volume is v is integral from 0 to 2. These are x values. And we're integrating with respect to x. And that's integral from 0 to 2. The differential volume is pi times 4 minus x squared, all squared dx. So basically, we're integrating the volume of all of these disks. And it's very important that you convince yourself that that's a differential volume, because it's simply differential volume is pi times radius squared. The radius is 4 minus x squared, all squared dx. It's very important that we get the right radius, because the rest of the question is very easy, but a common mistake is not having the radius set up correctly. So pay special attention to that. All right, let's do the computation. So volume is integral from 0 to 2 pi times 4 minus x squared, all squared dx. Let's pull the pi out, integrate from 0 to 2, 4 minus x squared. Let's open up the brackets, 4 minus x squared times 4 minus x squared. Now let's multiply this out and simplify. Volume is equal to pi, integral from 0 to 2, 4 times 4, that's 16, minus 4x squared, minus 4x squared, plus x to the fourth, minus times minus is plus. And let's simplify this and integrate with respect to x. Volume is equal to pi, integral from 0 to 2, 16 minus 8x squared, plus x to the fourth. Adding these two, minus 4x squared, that's minus 8x squared. We now integrate this with respect to x. We get volume is equal to pi, integral of 16, that's 16x. Integral of 8x squared is 8x cubed divided by 3. And integrate x to the fourth, that's x to the 5, divided by 5. Evaluated from 0 to 2. Now we apply the fundamental theorem of calculus. We substitute the upper limit in, subtract the lower limit. Volume is equal to pi. 16 times 2, that's 32. Plug 2 in, we get 2 cubed is 8 times 8, that's 64 over 3. Plus 2 to the 5 is 32 over 5. Minus pi, plug in 0 and we get 0 minus 0 plus 0. If you simplify all of this, the volume comes out to be pi times, well, let's actually show some of the algebra. If you take a common denominator, that's 15. 1 goes into 15 times, so you get 15 times 32, that's 480. 3 goes into 15 5 times 64, that's 320. 5 goes into 15 3 times 32 is 96, plus 96. If you add these all up and simplify, we get pi times 256 divided by 15. This is the volume of the solid. if we decimalize this, we get volume is equal to 53.62 units cubed. Whatever those units are, whether they're centimeters, meters, but the important thing is it's raised to the power of 3 because it's units of a volume. So we found the volume of revolution when we revolved it about the line y equals 4. All right, thanks.